Hello, I'm Mr. Klingler, and today we're going to talk about Kirchoff's laws. Kirchoff's laws are a way to help solve circuits. There are basically two rules which you probably already know. The first is the junction rule. It simply says the current into a junction is equal to the current coming out of a junction. This is not particularly insightful. What this really is amounting to is conservation of charge. All the charges that go into a place have to leave that place. The other rule is the loop rule. This says that the total change in voltage around any loop at all, has to sum to zero. This is actually remarkably insightful, but somewhat hard to use. This is based off conservation of energy. The energy anywhere around a circuit always has to sum to zero. There can be no net gains or losses. Now the steps for applying these rules are over here, and you should pause the video and take a moment to copy them down. We'll look at two examples in just a moment. First, you need to label the currents. How you label the currents is going to be completely arbitrary, but you need to pick a direction and a label for them. Once you've set these currents, don't change them. If it turns out you labeled a current incorrectly, which you probably will, don't worry, you'll just get a negative sign error when you solve for the current. Next, label your high and low voltage points for each resistors. This is based off the current you chose in step 1. Next, label high and low voltage for the battery. After that, you need to pick a starting point. I tend to pick my starting point near the back of the battery in the direction of current. I'll show you what I mean in a second. Finally, use the current rule and the loop rule. What you'll be solving for when using Kirchoff's laws is the current. It'll allow you to find the current through any branch. Let's take a look. Alright, this is a trivial example, but let's try it out. First, I need to label my currents. Well, this is the current coming out of the battery. I'll label this I1. I choose this direction because, intuitively, it seems like that's going to be the direction it goes. I go here, and I see that there are two possibilities. It's going to break out here and here. I'll label these I2 and I3. Once again, I'm guessing at the currents. This is probably a pretty good guess. Alright, now I need to label high and low voltage for each battery and each resistor. Well, for this resistor, this part would be high potential, and as I move across it, I would lose potential. That must be high and that must be low. Given the direction of this current, this must be high and this must be low. This must be high and this must be low. For my battery, the long part is the positive part. Okay, that seems reasonable. I'm going to pick a starting point in which to solve my circuit. I'm going to pick just behind this battery. Okay, let's see what we can do. My goal is to find I1, I2, and I3. Well, let's give it a shot. I recommend you always start with a junction rule. So I look at one of my junctions. What is the current coming into it? The current coming into it is I1. What's the current coming out of it? I2 is coming out, and I3. By the junction rule, these things must be true. I could have picked this junction. If I picked this junction, things would be different, or would they? Notice I'd have I2 coming in and I3 coming in, and together they would form I1. I realize that by picking this junction, I'm just creating the same equation again. That does me no good. You want only junction rules that provide unique equations. I'm done using the junction rule. I'm going to try the loop rule. I'm going to start here, and there are several loops I can talk about. I can talk about this loop. I can talk about this loop. And actually there's a third loop. I can talk about this loop. Notice this loop doesn't even have a battery. Well, we'll see what it looks like. Let's start here. The loop rule says the change in voltage is equal to 0. I apply this the following way. I start here, so 0 has to equal my change of voltage. Notice I'm going from negative to positive, so this must be a positive 12. I'm going to go across here, and I'm going to lose potential as I move across the 2 ohm resistor. I'm going from positive to negative. So minus, and using Ohm's law, I1 times 2 ohms. I'm going to now go down in this part, and this is going to be I2 times 3. I'm losing potential. I continue traveling, and I'm back to my starting place. My loop is done. Alright, so this is one of my loop rules. Let's try another loop rule. Let's take the outside loop. I would pause the video and try writing the outside loop. I hope your loop rule matched mine. I'm going to try one more loop rule. I'm going to start in here and go around this loop. Pay attention to the moves we make for this one. I'm going to go this way around the loop. So I'm going to start here. As I move this way, I'm going from negative to positive. So I must be gaining energy as I go across this resistor in that direction. As I come down, I'm going to lose moving across the 6 ohm resistor. I come around, and I'm back to 0. I've essentially written all of the unique equations I can for this loop. I would note that these aren't completely unique. You can't simply use these 3. These 2, when combined, would give you this. So, when choosing equations to use, always use as many unique junction rules as you can. And then use as many loop rules that are unique as you can. Determining which loop rules are unique, that's sometimes tricky. Well, we have algebraic equations. Now we just need to solve them. Let's take a moment to do this. I think the easiest way might be to plug I2 and I3 into here. Of course, if you're looking at this from home, you'll probably come up with a more clever way. Yep, that's all that I'm seeing at this moment. Unfortunate but true. So let's do that. I notice as I go through these that the algebra is going to start to get messy. That's not much fun. There are sometimes easier ways to solve this. One way will be using your calculator and matrices if you happen to know how to use matrices on your calculator. Otherwise, I'm afraid you're stuck with simply doing algebra. I'm not going to waste your time finishing the algebra. I apologize. We could probably finish solving this in the next few minutes, but I'd rather look at another example. Let's try another example. Wow. 2 batteries. This looks like a mess. I would note you could not solve this by reducing resistors. We're going to have to use Kirchoff's laws. Alright, let's try it. First, I need to label currents. If I were to label these currents, I'm pretty sure this battery is going to push the current this way. I'll call that I1. When the current gets to here, I have 2 options. Well, I think it's clear current is going to go that way. I'll label that I3. But what about this? This battery would tend to push the current this way. This battery would try to push the current that way. I'm going to have to guess. I'm going to make a poor guess. My poor guess is this. I think if we were to solve this, we would get the answers incorrect. Let's find out. And by incorrect, I mean this will give us a negative value when we solve for I2. I think this battery is so overwhelming that the actual current will be this way. So I think this is going to be a bad guess. We'll find out. What I'd like you to do is try writing the junction rules and the loop rules that are appropriate for this. I'm going to use the junction rule. I pick this junction. I1 plus I2 equals I3. I'm going to use the loop rule now. I'll pick here as my starting place. Almost forgot to label my pluses and minuses. That's this loop. This one is this loop. Pay careful attention to your positive and negative signs. Oops. Good catch. There we go. I have 4 elements, so I should have 4 elements in my loop. That could have been bad. The other loop I could use is this loop. When choosing loop rules, I try to pick loop rules where I'm always moving with the current. Sometimes that's not possible. Keep in mind, this is just a combination of these two. So the 3 equations I would end up using, maybe those 3. If I don't like those 3, I could pick any 2 of these 3 loop rules. Hope this was informative. Thank you.